This sequence says it is a sub n, and it's determined by n minus 5. This is not an. An is an indefinite article that we use in the English language. This is rather a sub n, okay? So a sub 1, or the first term, is equal to simply 1 minus 5, which is negative 4. And a sub 2 would be 2 minus 5, which is, and a sub 3 would be negative 2, and a sub 4 would be negative 1. Yes. Nope, start with 1. We don't talk about the 0 term. We talk about the first term. So you notice that the term number is always an integer. Does that mean that this will always be an integer? No. Okay, what would be the fifth term? Yeah, you can see it's obviously going up by 1 each time. Very easy to see. The 100th term, a sub 100, would simply be 95. Now, somebody noticed, Emu noticed the other hour that the difference here is 1 and 1 and 1. So the first difference is constant, and thus it is linear. It's to the first power. So that's absolutely correct. As we look at this one, we determine a to the 1 is, or a sub 1 is 4. A sub 2 is 10. A sub 3 is 18. And a sub 4 is, yeah. So maybe you can look here and see, well, this one goes up by 6, then by 8, then by 10. The next one would be go up by 12, so we would have 40, right? Okay. And so if you want to do a sub 100, you would get 300. What is 100 squared? 10,000. So we get 10,300. Oh, what Emma was bringing up during third hour was that this difference right here is 6, this is 8, and this is 10 as I talked about, but the second difference is always 2, and maybe that's what Jake was referring to as well. That means the second difference is constant, and thus you know it is squared. So when the first difference is constant, it's 1, second difference is constant, it's squared, okay? Now, I know that you guys can look at that, predict the next number, but let's look at this example, okay? A sub 1 is what? 3/5. A sub 2 is 1. A sub 3, 9/7. And a sub 4, yeah, 4. So we get 12/8, which is 3/2. So look at these numbers: 3/5, 1, 9/7, 3/2. Would you be able to predict the next number out of that just by, if you weren't given the rule? Be kind of difficult, wouldn't it? Imagine if you were given those and you had to try to write a rule. That would be very challenging. You have to appreciate that generating them is a lot easier than finding the original rule. Okay, look at this one. A sub 1 is 2 to the, which is 1/2. A sub 2 is 2 to the 0 is 1. A sub 3 is, and a sub 4 is 4. And it's easy to see that every time you're multiplying by 2. So in this case, a sub 100 would be 2 to the 98th power. Yeah, that was a big number, so we'll just leave it like that. Okay. I forgot to do a sub 100 over here. A sub 100 would be 300 divided by 104. Or 150 over 52, or 75 over 26, whatever. Great. Let's do one more, okay? And you can see again how it's difficult to make predictions about the type of rule that we have. Here we have 4n plus negative 1 to the nth power. A sub 1 is 4 plus 1 or minus 1? Minus, and I get 3. A sub 2 is 8 plus 1 or 8 minus 1? 8 plus 1, and I get 9. A sub 3 is 12 plus 1 or minus 1. So you get 11, and then A sub 4 is 16 plus 1 or minus 1. You get 17. So you can see that it goes up by 6, then it goes up by 2, then it goes up by 6, and then it'll go up by 2, so on and so forth. So, kind of difficult to see exactly what's happening. In this one, we have A sub 100 would be 400 plus 1 or minus 1. We get 401. What? All right. So the easiest type of sequence to deal with is what we call an arithmetic sequence. Here's an example of an arithmetic sequence. -3, 1, 5, 9. What's the next term? 13. So an arithmetic sequence has what we call a common difference. And it is linear. We are going to learn to write rules for arithmetic sequences. You already know how to do it because you know how to write equations that are linear. The difference is equal to, if you take A sub n plus 1, I'm sorry, A sub n plus 1, and you minus A sub n. So if you take the next term minus the current term, you're going to get the difference. And all that means is if you take 13 minus 9, you get 4. If you take 9 minus 5, you get 4. If you take 5 minus 1, you get 4. If you take 2 consecutive terms and subtract them, you should get that common difference. The way that we come up with the rule, or the A sub n term, is you take the first term and you add to it the difference times n minus 1. It's a very easy formula that we can derive. So let's try these examples. We have A sub 1 is 5 and the difference is 3. So what's going to be the next term? 8, then 11, 14, so on and so forth, right? Now, as you look at this, I could say, what's the 20th term? And you guys would say, well, the 20th term, all I would have to do is just, do this 20 times and see what I come up with. Well, what if I said, I want you to find the 2000th term? All of a sudden, that would be a little bit more difficult, wouldn't it? A little bit more challenging. So let's just write a rule. We know what the rule is. A sub n is equal to the first term. What's the first term? Plus the difference times n minus 1. And there's our rule. So you could plug in 20 right now, and that'll give you the 20th term. Or what's most commonly done in this situation is we combine like terms. We get 5 plus 3n minus 3, or A sub n is equal to 2 plus 3n. Try B on your own. I'm sorry, I forgot to go back and find the 20th term. If you plug in the 20th term here, you get 2 plus 60, which is 62. In this situation, A sub 20, you get 102 minus 40, and you get 62. You notice in both situations, you get 62. It turns out that in every arithmetic sequence, A sub 20 is always 62. Actually, I'm lying. That's not the case at all. Okay, that's just by chance. Okay. Yeah, it's called the rule of 62. Thank you, Jake, for laughing at my joke. Jill did not. Doesn't find math a funny matter. She says it's serious business. Fine. Let's get serious. What's the next term in the sequence? 13. You can see the common difference is equal to 4. So therefore, a sub n is equal to, what do I write? -3? Good job. So a sub n is equal to 4n minus 7. So therefore, a sub 20, according to the rule of 62, is 62. Or not, because that's not a rule. We plug in 20 and we get 73. What's the difference for the next one? I like what you said about the minus 1 over 2, but what do you mean by n? We'll just, here, so hey, so we'll just say the difference is, as Braden said, -1 over 2. So as you take one of the terms and subtract the one previous to it, you get -1/2. Because 39 over 2 is 19.5, and 37 over 2 is 18.5. So you subtract the terms, you get a -1/2. So I've got a sub n is equal to, first term 20 minus 1/2 times n minus 1. Or a sub n is equal to 20 minus 1/2 n plus 1/2. Or a sub n is equal to 20 and 1/2, so you could do like 20.5, or maybe you want to do 41 over 2 minus 1/2 n. I actually like to write it as 41 minus n all over 2. There's a couple different ways you could write it. That's the way I roll. So if you want to find the 20th term, plug in 20. 41 minus 20 is 21 over 2. Not too bad, huh? Easy peasy. So the second one we're going to learn about today, and then we're done, so we just got to finish these 6, is the geometric sequence. Here's a geometric sequence. What is the next term in that sequence? 81. Why? What are you doing each time? A geometric sequence has a common ratio. Instead of linear, it is what we call exponential. If you want to find the ratio, simply take two terms and divide them. So a sub n plus 1 divided by a sub n. Or in other words, if you take 81 and divide by 27, you get 3. 27 divided by 9 is 3. So on and so forth. So the geometric sequence is, the rule for is a sub n is equal to the first term, a sub 1, times the ratio to the n minus 1 power. It's a very simple rule. In this situation, we have a sub 1 is 2 and r is 3. What's the first term in the sequence? 2. What would the next term be? 6, then 18, 54. We're multiplying each one by 3, correct? That's how the sequence is generated. Let's find a sub n. A sub n is first term, which is times the ratio raised to the n minus 1. Can you take the 2 times 3, you get 6? No, that's totally illegal. Thank you for saying no. But what if we changed it? What if we changed it to this? What if we said a sub 1 is 3 and r is 3? That means the first term would be 3, and then 9, and then 27, and so on and so forth. Kind of like what we had before, right? So you're going to have a sub n is equal to 3 times 3 to the n minus 1. This is 3 to what power? And if we have common bases, what do we do the exponents? And what is 1 plus n minus 1? N. So you can see that in that situation, you could kind of combine things together and have 3 to the n. See that? A little tricky. Let's do the next one. 64, r is 1/2. What's the first term? 64, what's the next term? Oh. I said, what if? Let's suppose that so this is problem A. This is like problem 8.2. I don't know. Okay, so I just made another problem. It doesn't just change to 2. I said, let's just suppose instead of a 2, it was a 3. This is the answer there, and then this would be the answer for that part. Sorry. See that catch by Buxton last night? Dude laid out. Then he had a triple. Guy's fast. He's starting to figure it out. How to hit pitches that are off speed in the big leagues. That's a big deal. All right. First serve is 64. Next one's 32. What's one after that? 16, 8, so on and so forth. Okay, you're multiplying each one by 1/2. So if we want to figure out a sub n is the first term, 64, times what? 1/2 to the n minus 1 power. Now, I don't think the book would do this, but I just want to be clear that you can rewrite this a little bit. Watch what I'm going to do. I'm going to write this as 128 times 1/2. Isn't that what 64 is? Times 1/2 to the n minus 1. Well, now can I combine those 1/2s together to get 128 times 1/2 to the nth power, right? Well, what's 1 to the nth? What's 1 to any power? 1. So you just get 128 over 2 to the nth. So, this is the way that most students will write it, and that's acceptable. I just want you to understand that that's the same thing. I didn't realize it when I first started teaching, but without a doubt, one thing that we tend not to like as much as students is exponents and how we deal with them. I'm getting a nod over here. Getting sleepy eyes over here. All right, let's finish up. We got 4 left. 1, 3, 9, 27. What's the ratio? Ratio is 3. What's the next number in the sequence? It would be 3. It would be 81. Very good. So we have a sub 1 or a sub n is equal to first term, which is 1, times r, which is 3 to the n minus 1. That's it. What's the ratio here? Negative 1/4. So a sub n is negative 200 times negative 1/4 to the n minus 1. What's the ratio here? Root of 3. First term is 1, so we have a sub n is 1 times the root of 3 raised to the n minus 1. I don't like that. I don't like a radical raised to power like that. The square root of 3 is the same as 3 to the what power? So you could see it's written as 3 to the n minus 1 over 2. You don't like that? You understand that one? All right. Do you understand that Miguel Sano is going to be a MVP someday? I love watching that guy swing the bat. I don't even care if he strikes out. I just watch him swing the bat. It's like, holy cow. All right, here we go. A sub n. What is the r value here? Who can tell me? Negative 2 over 3. Terry, how on earth did you learn that? How did you see that? What did you look for? Tell us your secret. Okay, so you just looked at the tops first. You're like, oh, I'm multiplying the top by 2 every time, or maybe negative 2. And the bottom, if I write that by 1, then I've got 3 on the bottom. If you ever get confused, here's all you have to do. take two terms, say 32 over 9, and then divide it by the previous term, negative 16 over 3. If you multiply by the reciprocal, notice that you are going to get negative 2/3. This gives you 3 in the denominator, negative 2 in the numerator, negative 2/3. So we've got 8 times negative 2/3 raised to the n minus 1, done and done. When we can write rules, it's good. Arithmetic and geometric, you can always write rules. There's some of them it's pretty difficult to write rules. You have 20 minutes, which is more than any class got, to be able to do your homework. And here's your homework. Now, I know it looks odd, but here's the deal. I can't stand the way, sorry, Mr. Stewart, if you're watching the video, I can't stand the way that your textbook addresses this topic. I like to talk about all the sequences first. What they do is they talk about arithmetic sequences and series and stuff. So whatever. So each one of these sections talks a little bit about sequences. This is a general one. This is arithmetic. This is geometric. There's 5 problems in each section. That's a total of 15 for you math majors out there. I would like to be clear that 15 problems really isn't too much. We did about 24 or so in class today together, so you shouldn't have any problem. In fact, I think the majority of you can finish it before the hour's over. You may take a nap if you so choose, or if you need to catch your breath and try to wake up a little bit, you could take a lap around the e-house, come back, and you'll be refreshed. That's a good point. All right, folks, go be leaders.